Hello everyone, and welcome to yet another math video. In this video I will go over how to solve equations that are quadratic in form. And all of the examples I plan to go over will involve factoring. So in the very first example here, you can see we have x to the fourth minus 5x squared equals negative 4. And you may be wondering, how is this quadratic in form? What makes this work like a quadratic equation? Well, once you get 0 on one side of the equation, like this, what you can do is look at the exponents on the variable. So when you look at the exponents, the bigger exponent is 4 and the smaller exponent is 2. The bigger exponent is twice as big as the smaller exponent. And that's how you know you can solve this using factoring. So how does that work? Well, it still isn't quadratic, but it would be nice if we could make it quadratic. And you can do that by taking the variable and the exponent from that middle term and making it equal to u. And effectively what that does is it changes the equation into something quadratic. Like this. So the middle term, the variable just becomes u, as you can see here. And the variables and exponent on the first term become u squared. Every single time this will happen. And I'll explain this once here, and that's because if you square both sides of this equation, you will get u squared equaling x to the fourth power. So the x to the fourth power becomes u squared. But from here, this makes the factoring a lot simpler. So this becomes u minus 4 times u minus 1 equals 0. And that's fine. You can set these equal to 0 and solve for u, and you'll get u equals 4 and u equals 1. The problem here is that the equation way back up here, the original equation, started with x's. But we have answers in u's, and that's not going to work. So what we do is we come back here to where we said u equals x squared, and we just replace the u back with an x squared. This is known as back substitution. And then from here, we can use the square root property to solve these. Don't forget the plus or minus in front of the number. The square and the square roots cancel, leaving you with x equals plus or minus 2 and x equals plus or minus 1. And these four answers are good answers. Now, if you know anything about solving polynomial equations, or at least solving quadratic equations, you might remember that the large whole number, the bigger whole number exponent, tells you how many answers you have, and this still holds true in this equation. But if you look at example 2, this is an exponent 2/3 and an exponent 1/3. Because these exponents are not whole numbers, I cannot tell you how many answers we are supposed to have at the end. That only works when the exponents are whole numbers. So anyway, let's take a look at this example 2. It looks like we have our equals 0. So that middle term, x to the 1/3 power, that's what u will be, giving us an equation that looks something like u squared and u minus 13 plus 40 equals 0. So all that happens is that the variables get replaced with a u and a u squared. From there, you can factor. This becomes u minus 8 and u minus 5 equaling 0. which gives you u equals 8 and u equals 5 when you solve for u. But again, way back at the beginning, we started with x's, so we need to end with x's. So we just make that back substitution, replace u with x to the 1/3 power equaling 8, and x to the 1/3 power equaling 5. Now really, these equations that you see here at the end are just cube root equations in disguise. What ends up happening here in the middle is that when you have an index that I'm going to call n and a variable inside of it, that's the same thing as writing x to a fractional exponent. So really, we can think of this x to the 1/3 power as a cube root. And if you want to solve a cube root equation, then you would raise both sides to the index power, the third power. So when you have x to the 1/3 raised to the third power, that gives you x, and then 8 to the third power is 512. X to the 1/3 power to the third power in the second equation is also x, and 5 to the third power is 125. So in this case, we got two answers. All right, let's move on to the final two examples for this video. And what I will do here is just reveal steps slowly so you can see how these equations are solved. Okay, so here are the answers for example 3. What happened? Well, you can have an entire binomial or set of parentheses, an entire expression, have twice the exponent of the middle term. And so when that happens, you set that entire expression equal to u and make your substitutions. You can still see the -4 is here, the -21 is here, the equals 0 is here. Once you make that substitution, you factor and solve for u, then back substitute the u's for 2x minus 5, and then you solve that equation to get x equals 6, and this equation to get x equals 4. And something similar happens over here in example 4, except that in this case, you can see it is a 3 over c plus 5 being squared, and a 3 over c plus 5 to the first power. I am, in fact, missing an equals 0 here, so there it is. From there, the middle term, all of this will turn into u, which means this whatever's being squared is u squared, and we have this plus 6 minus 8 equals 0. Also, as a quick note, I want this to be plus 8, so the factoring will work. So then we can factor this and get u plus 2 and u plus 4 equaling 0, which tells you u equals -2 and u equals -4. Make your back substitutions like so, and you can see that we now have two rational equations. And what I will do is I will solve one of these, and you can solve the other one very similarly. So the first thing you will want to do here is make sure you are multiplying by the LCD. And the LCD is just c, because there's only one denominator. And this leaves you with the equation 3 plus 5c equals negative 2c, which then you can solve for c now that it is a linear equation, and you can see that the answer will be 3/7, negative 3/7 for c. So that's one answer. If you do something similar over here, you will end up with c equals negative 3/9, which in fact simplifies to negative 1/3. Thanks for watching. See you in the next video.